we're going to look at the graph of tangent x. We're not going to spend a whole lot of time with this because the shifting and all that stuff behaves the same way with tangent. But we are going to look at it nonetheless, and we are going to refer back to the unit circle to help us out with this. So the tangent of 0, remember tangent is sine over cosine. At 0 degrees on this unit circle, the tangent there is 0. The tangent of pi, which is right here, is also 0. The tangent of 2 pi is also 0. So the multiples of pi, the tangent is 0. If we look at pi over 2, that's up here. The tangent there is undefined. So what we have at pi over 2 is an asymptote. And we'll have the same thing at negative pi over 2, at 3 pi over 2, negative 3 pi over 2. These are all asymptotes on our graph. Now if we look at pi over 4, that's there. The sine and cosine are the same, so the tangent is equal to 1. Negative pi over 4, sine and cosine are opposites, so the tangent is negative 1. The tangent graph looks like this, and the branches keep getting repeated over and over. Pardon my bad graph. In your graphing calculator, a lot of times you'll see this like that because the calculator's connecting the dots on the graph and it's showing the asymptotes. If we throw in some pluses or some multiplications, the shifts and the stretches behave the same. The only difference in this equation is that the period of these isn't 2 pi, it's pi. So in our equation, it'd be pi divided by b. To solve this equation, we're going to solve it using the graphing calculator. What we're going to do is we're going to put the left side into y1, the right side into y2, and we can look at our graph and we can manipulate the window so that we can see the whole thing. I put in my x minimum as negative pi over 6, my x maximum as 13 pi over 6. That way I can see everything from 0 to 2 pi. And I have my scale be pi over 6 just to fit with this trigonometric setting that I have. The other thing is in mode, you do need to be graphing in radians. And I can see from this graph that there are 3 solutions, 3 intersection points to these equations. And I can calculate what these are. I'm going to hit second, trace. Choice 5 is intersect. And if I want this middle one, I select my first curve, it says y1. Second curve is y2. I move my cursor near to where that intersection point is and I push enter. So my intersection point to 3 sig figs would be 3.28. I could find this first one, the leftmost intersection point, by moving my guess closer to that point. And I would just need to do this 3 times to find my 3 solutions for x. When it asks for the analytic solutions, it's asking for the exact solutions. And anytime it's doing this, we're going to be referring to the unit circle. So I want the sine of something that's negative 1/2. I'm going to draw a little sketch, just real quick like. Negative 1/2 being the sine, that's the y coordinate that would be this angle. So 2x is equal to 11 pi over 6. But then it's also equal to multiples of 2 pi. Because that would give us coterminal angles, that is, angles in the same position but just spun around the circle more times. Or there's another angle in the third quadrant that has negative 1/2 as its sign. So I could also say that 2x equals 7 pi over 6 plus multiples of 2 pi. To figure out what x is now, I divide both sides by 2. I get 11 pi over 12 plus this becomes multiples of pi. Or x is 7 pi over 12 plus multiples of pi again, because I have to divide everything by 2 here. Now I have to find the actual solutions. I know that 11 pi over 12 is within 0 to 3 pi. I also have 7 pi over 12 as a solution. And I can add on pi to these things. So 11 pi over 12 plus 12 pi over 12 would be 21 pi over 12. I can try adding on another full pi. So 21 pi plus 12 pi over 12 is 33 pi. I'm sorry, this is 23 pi over 12, and this would be 35 pi over 12. If I add on one more full pi, I'm bigger than 36 pi over 12, which is what 3 pi would be. And if I try and subtract 12 pi over 12 from 7 pi over 12, I go negative. So there are 4 solutions to this equation. Here again, I want the exact solutions between negative pi and pi. So I'm going to think about my unit circle. I want the tangent to be 1. And that's going to be in the first quadrant and also in the third quadrant. So this 2x minus pi over 3, that could equal, well, this would be 5 pi over 4 plus multiples of pi, because remember, tangent has a period of pi, not 2 pi. Or this 2x minus pi over 3 could equal pi over 4 plus pi times k. And now I just need to solve. I add pi over 3 to both sides. This would be 19 pi over 12. I needed a common denominator. I think that's what it is. Let me double check. Yeah. Plus pi k. Divide by 2 on both sides. And I get that x is equal to 19 pi over 24 plus multiples of pi over 2. From the other one, I add pi over 3 to both sides. 2x equals 7 pi over 12 plus pi k. Divide by 2, I get x equals 7 pi over 12 plus pi over 2. Okay, so multiples of pi over 2. If I add on 6 pi over 12, I get another solution, which would be 13 pi over 12. If I add on another, but that's bigger than pi, so that's not a solution. If I subtract 6 pi over 12, I will get just pi over 12 as a solution, and that falls within this range. And I can keep subtracting 6 pi over 12, so negative 5 pi over 12, negative 11 pi over 12. These are all solutions from this first one. Now I look at 19 pi over 24. Oh, I made a mistake there, didn't I? That should be a 24. This is going to affect these answers that I have down here. So I'm really adding on 12 pi over 24, which would give me 19 pi over 24, which I already have. I can add on another 12 over 24, which gets me bigger than pi. So far I have 7 pi over 24 and 19 pi over 24, and I can subtract that 12 over 24 pi, that pi over 2, in addition. So 7 pi over 24 minus 12 pi over 24 is negative 5 pi over 24. And if I subtract another pi over 2, I get negative 17 pi over 24. And if I subtract again, I get beyond the negative pi. So again, in this problem, I have 4 solutions. We can rearrange this equation to give us a tangent. Tangent of x equals, and it's just a matter of dividing by cosine and then dividing by the square root of 3. Tangent of x equals 1 over the square root of 3. Since I want exact solutions, that means the answers are coming from the unit circle, and I know that the square root of 3's on the unit circle have to do with pi over 3 and pi over 6. And the question becomes, which one of these two angles is it? And I don't have this memorized. I just simply try one of them, and if it doesn't work, it's got to be the other one. So tangent is sine over cosine. I'm going to try the pi over 6 angle. So we take 1/2, divide it by square root of 3 over 2. That's 1 over the square root of 3, which is what I want. So x is equal to pi over 6 plus multiples of pi. So within our unit circle, we have pi over 6 as a solution, and also 7 pi over 6. 2 solutions for this equation.